Fish live in water. So how could they possibly get seasick? Stop and think about that for a second. Seasickness is what happens to us, on a boat, bobbing around on top of the water. Fish are already in the water. That's their whole thing. So a fish getting seasick should be a contradiction. Except it's not. Scientists have actually made fish motion sick, on purpose, in a lab. And when they went looking for why, the answer was hiding inside the fish's ears. In 2003, researcher Kai Helling sealed 22 swordtail fish inside an aquarium, then rotated the tank around one axis while rocking it around another, at the same time. Basically, a fish blender minus the blending. At first, every fish adjusted, fighting the motion to stay oriented. But as the intensity climbed, 3 fish stopped compensating. They went limp and uncoordinated, tumbling along with the motion instead of resisting it. When the motion eased, those 3 recovered. So the researchers did what any good scientist does next. They cut the fish open and looked at their inner ears. All 3 fish that lost their balance had something in common. Inside their ears sit otoliths, tiny mineral stones resting on hair cells that tell a fish which way is down. In these 3 fish, the otoliths on the left side didn't match the ones on the right. One fish had the mismatch in a second structure too. The fish that got seasick were the ones whose internal gravity sensor was already a little lopsided, not broken, just slightly out of balance, in a way you'd never notice until you put that fish through the exact wrong kind of motion. Here's where it gets ridiculous. Researchers didn't stop at spinning tanks. They sent fish through actual weightlessness on parabolic flights, the same maneuver used to train astronauts. Some fish started spinning, looping, corkscrewing through the water with zero control. Scientists have a real name for this: kinetosis, fish motion sickness. Once again, the fish that lost it hardest had the most asymmetric otoliths. Meanwhile, when researchers recreated similar forces on the ground using ordinary acceleration, the fish were fine. It wasn't acceleration that broke them, it was the loss of normal gravity itself. In some experiments, goldfish in short bursts of weightlessness only spiraled out of control when they also lost a clear visual reference point. Give them something to look at, and they could partly steer using their eyes instead of their inner ear. Then the strangest finding. Some fish are born without gravity-sensing otoliths at all. You'd expect that to make things worse in zero gravity. It's the opposite. They spent less time spinning out of control than normal fish, because they never had a working sensor to get confused in the first place. Nothing to contradict, nothing to fight. It's a little like how a person who's never had working eyesight doesn't get fooled by an optical illusion. You can't be betrayed by a sense you never had. So what's actually going on? It's the same basic glitch that makes humans seasick. Below deck on a ship, your inner ear feels the rocking, but your eyes see a room that looks still. Your brain gets 2 conflicting stories about what's happening, and that mismatch is what makes you sick. Fish run the same system: eyes, inner ear, and a brain trying to reconcile them. Push a fish through motion or gravity strange enough, and those signals stop agreeing. The nervous system loses the plot, and so does the fish. It doesn't matter that the fish has spent its entire life underwater. The confusion isn't coming from the water, it's coming from a mismatch happening entirely inside its own head. Now, before you go around believing fish get seasick every time waves roll through, that's not what this shows. These are lab extremes: engineered spinning tanks and actual weightlessness. Nobody has proven ordinary ocean swells make wild fish sick the way a choppy ferry ride gets to us. But the deeper point still stands. A fish doesn't need to leave the water to get motion sick, because motion sickness was never really about the ocean. It's about a nervous system getting conflicting signals about which way is down, and that problem doesn't care whether you're a human on a cruise ship or a swordtail fish in a spinning aquarium. If that broke your brain a little, hit subscribe. Next week's animal might be even weirder. See you then.